There's a mystery buried in the Scottish Highlands, and it starts with a number: 1%. That's how many Scottish men carry a genetic signature. Not from the Isles, not from the Norse, not even from continental Europe, but from the sun-baked mountains of North Africa. A Y-DNA marker known as EM81, the same marker that defines the Berbers, the Amazigh, a people who've roamed the Maghreb for thousands of years. 80% of Berber men carry it. In Morocco, Algeria, the Atlas ranges, it's ordinary, expected. But in Scotland, where clans once carved their crests into stone and stood against Rome, it's an anomaly, a contradiction so sharp it forces us to ask, how did this Berber bloodline cross oceans and epochs to land in the DNA of Celtic warriors? The textbooks are quiet. They tell us the Celts came west from Central Europe, settled the British Isles, and remained mostly isolated. They don't mention a Saharan thread, stitched deep into highland lineages. But DNA doesn't follow clean maps. It remembers what history forgets. The marker EM81 is ancient, born over 14,000 years ago in North Africa. It survived Sahara expansions, Roman conquest, Islamic rule, and still today it pulses strongest in the Amazigh, who call themselves the Free People. But here's the twist. That same marker has been found in trace amounts across the Iberian Peninsula, in southern France, and all the way north to Orkney and the Outer Hebrides. It follows the Atlantic coast, like a fading echo, like a forgotten migration carved into the genome. And it dates back not to recent history, not to the Moors or Romans, but to something far older. Genetic modeling points to a potential arrival around 5000 to 3000 BCE, before Carthage, before Celtic tribes had even formed. So the mystery deepens. This wasn't a medieval invasion. It wasn't a soldier's footprint. It was something older. And if the Celtic bloodlines didn't go south, then someone from across the sea, from across the dunes, came north. But the first clue, it wasn't in the Y chromosome at all. It came from a different direction, from the mother lines, from mitochondrial whispers. And she crossed oceans, but not in galleons or warships. She sailed before history remembered sails, long before maps, before borders, before the word Europe had meaning. Around 5200 BCE, 5,500 years before today, her people crossed the narrow waters between Africa and Iberia, the Strait of Gibraltar. A 14-kilometer breach between continents, but for them, it was a lifeline, a forgotten bridge. Today, we call them Neolithic migrants, but what they carried was more than farming tools. Their pottery, cardial ware stamped with seashells, fired in open flames, is found in caves from the Moroccan coast to Catalonia. That style doesn't drift by accident. It spreads by memory, by hands trained across generations. Tracing this trail is like finding fingerprints across the stone walls of time. And yet, what's buried beneath that clay is even more revealing. Because the genetics match. A 2023 study of ancient Moroccan farmers dated between 5400 and 4900 BCE revealed that their DNA wasn't fully African. It contained lineages from early European agriculturalists, migrants from the Mediterranean, who had circled down into the Maghreb. The same mitochondrial haplogroups U6, K, and N1 appear in both Iberian and North African skeletons from the same era. Not echoes, not coincidences, shared ancestry. So when we say someone crossed, we don't mean once, we mean back and forth, over millennia. A dance of cultures planting barley in new soil, burying their dead under megalithic tombs that resemble each other so closely. Early French colonists in Algeria in the 1862 thought the dolmens of Jebel Mazella were Gallic ruins. They weren't. They were African, or European, or maybe both. But they weren't primitive. These early seafarers shaped the first Atlantic civilizations, before the Celts, before the Moors, before anyone knew to call themselves anything at all. And within those communities was one woman. Her body was never found, but her genetic legacy would whisper through time. Mitochondrial haplogroup U6, a maternal lineage rooted not in Europe but in North Africa. Her descendants show up in medieval Portuguese cemeteries, in bones pulled from caves in Tafaralt, Morocco, dating to 12,000 years ago. And yes, even in the edges of Ireland. So who was she? We don't know her name, but we know her echo. And in the next breath, we'll follow it, through fire, famine, and frozen silence to the Ice Age mother who carried that flame across time. Her signature lives on, not in writing, not in monuments, but in a microscopic code passed from mother to child, untouched by fathers, by kingdoms, by conquest. It's called haplogroup U6, a mitochondrial fingerprint, and it is one of the oldest maternal lineages on Earth. U6 didn't begin in Africa. That's the twist. It started its journey in Paleolithic Eurasia, possibly in the Levant or the Caucasus nearly 45,000 years ago. But by 25,000 BCE, it moved south, in what scientists now call a back-to-Africa migration, long before agriculture, before metal, before writing. These were the last Ice Age wanderers, and they changed everything. Today, U6 is considered the defining maternal marker of the Berber people. It reaches up to 20% in certain North African groups, particularly the Mozabites, Klea, and Saharan Tuareg. But its story doesn't stop in the dunes, because U6, like the people who carried it, moved again. In the 2018 genomic study of the Guanches, the first inhabitants of the Canary Islands, researchers found U6b in nearly all recovered remains. The Guanches, isolated for centuries, held onto the oldest Berber DNA in the Atlantic world, and yet fragments of that same lineage appear in Neolithic Spain, in northern Portugal, even in the misty edges of Western Ireland, less than 1% in the Isles but unmistakable. The connection runs deeper than data. In both Berber and Celtic traditions, we find a spiral, etched into tombs, woven into cloth, painted onto skin, a symbol of cycles, of mothers, of time itself. Coincidence? Maybe. But what if it's more than that? What if this spiral was not just a pattern, but a memory, a cultural echo of a maternal line that once spread from the Atlas Mountains to the green coasts of Europe? And still, U6 isn't the oldest. Beneath even that, another mother waits. An even older maternal line. From the heart of Ice Age Europe to the stone graves of North Africa, she left a trail. And that trail leads straight into the bones of the Sahara. From the heart of Ice Age Europe to the stone graves of North Africa, she left a trail. And that trail leads straight into the bones of the Sahara. But her legacy didn't vanish in the sand. It survived. Beneath the silence inside a rare branch of mitochondrial DNA called U5B1b. First sequenced in the ancient remains at Tafaralt, northeast Morocco, dated to nearly 15,000 BCE, U5B1b shattered every theory about who lived and migrated in the post-glacial world. These weren't farmers, these weren't North African natives, they were Ice Age hunter-gatherers who had somehow crossed into Africa while the world was still thawing. And here's the shock. That same exact maternal lineage, U5B1b, is also found in the far north, among the Sami people of Lapland, Scandinavian reindeer herders who have roamed the Arctic tundra for centuries. Thousands of kilometers apart, No shared language, no recorded contact, but the same mother line. That's not a coincidence. That's memory, buried in the genome. It points to something older than nations, older than civilization. A people who once lived in the shadows of the ice sheets and left behind daughters who scattered into two worlds, one north, one south. The Franco-Cantabrian Refuge. That's what scientists call it, a belt of caves stretching from southern France to northern Spain, where humans survived the last glacial maximum 20,000 years ago. It was a frozen sanctuary, and possibly the shared origin of both Celtic ancestors and early Berber gene pools. From there, some moved north, chasing the retreating ice into what would become Finland. Others turned south, crossing the Strait of Gibraltar, planting roots in Morocco, Algeria, and perhaps even earlier into the Maghreb. What ties them together? It's not just U5B1b. In the caves of El Castillo in Spain and Tassili Najer in Algeria, we find the same ancient art: painted deer, horned spirits, concentric animals circling the rock. Two continents, same hands, or the same story? Either way, this was not the end of migration. Because while the mother lines whisper, the father lines hide, and inside them, a different code waits. One that rewrites everything we thought we knew about Celtic blood. Because while the mother lines whisper, the father lines hide, and inside them, a different code waits. One that rewrites everything we thought we knew about Celtic blood. That code is R1b, a Y chromosome haplogroup passed only from father to son, and it dominates Western Europe. Nearly 80% of men in Ireland, 2 out of 3 in Wales. Across Scotland and the western edges of France, R1bM269 is the undisputed genetic backbone of what we call Celtic Europe. But there's a fracture in the pattern, because in the heart of Africa, in the Sahel, across Chad, Cameroon, and northern Nigeria, another version of R1b appears. Not M269, but V88, a different branch from the same tree. And in the Berber highlands of North Africa, it appears again, in small traces, 1, maybe 5%, but unmistakable. So how did a Celtic signature end up in desert tribes and Saharan farmers? The answer lies in a world long erased. A Sahara that wasn't sand, but grass, a green ocean of life. Between 8,000 and 5,000 BCE, during the African humid period, the Sahara bloomed. It was a cradle of cattle, of ritual, of movement. Rock art in Niger shows horned bulls, boats, herders, not a desert, but a highway. And that highway stretched east to west from the Nile to the Atlantic. Long before Indo-Europeans rose, before Egypt built pyramids, men carrying R1b V88 were already moving. Some settled in Central Africa, others reached the Mediterranean, and some, it seems, crossed into southern Iberia, perhaps by boat, perhaps by caravan, long before written history could record them. So now we ask, was the Celtic fatherline really born in Europe? Or did it first echo from a forgotten Saharan king? In 2010, researchers analyzing R1b 88-inch Chadic speakers proposed a back migration route. That R1b didn't just flow north to south, but south to north, looping back into Europe from Africa around 7,000 years ago. This isn't just genealogy. It's a buried network of men stepping across a green Sahara, carrying a flame that would one day light the Celtic fringe. But these genes didn't just walk. Some of them sailed. And those sails, they left traces in the bones of Irish shores. Traces no one could explain, until now. Because deep in the earth beneath Navan Fort, an ancient royal site of the Ulayed kings, archaeologists made a discovery that cracked time open. A skull, Not human, not native, a Barbary ape, genetically identical to those still clinging to the cliffs of Gibraltar, dated to around 400 BCE, centuries before the Roman Empire ever reached Ireland. How does a monkey from North Africa end up buried in the political heart of prehistoric Ireland? You don't carry a wild animal across oceans without purpose. It wasn't for meat, it wasn't for war. It was a gift, an offering, or perhaps a message. And that message goes both ways. Because across the sea in Tunisia, a miracle surfaced, thousands of crushed shells, dog whelk, from the cold waters of the Atlantic. These weren't natural debris, they were processed, boiled, cracked for dye, Tyrian purple, the colour of kings. But these shells didn't belong there. They came from Ireland, from Scotland, from a people the Mediterranean world barely acknowledged. The earliest known maritime trade routes from North Africa to Iberia are dated to at least 2000 BCE. But what these finds suggest is something bolder: pre-Phoenician contact, possibly Neolithic, entire centuries earlier. Not legends but relationships, quiet exchanges over generations, no empires, just memory. And memory floats. In 1999, archaeozoologist Dr. Eileen Murphy confirmed the ape's remains in Navan Fort matched North African genetic profiles, and the dye shell clusters in Tunisia were analyzed by marine biologists in 2006, who linked their species to Irish coasts. Two discoveries, same whisper. So maybe what we're seeing isn't trade, it's trust. Lineages that once knew each other, not through conquest, but through kinship. And still, this was only half the message. Because culture travels in things, but identity travels in words. And now we turn to the last survivor of that ancient dialogue, a language that no one expected to connect. Yet buried in Celtic grammar is something no European tongue should carry. Something Afro-Asiatic. It sounds like heresy to a linguist, a contradiction so deep entire careers were built to disprove it, but in the 1952nd, an outsider saw it first. Heinrich Wagner, a German scholar fluent in Irish, Berber, and Basque, noticed something no one else dared connect. Two languages, worlds apart, no shared empire, no colonial contact, and yet built on bones that looked eerily alike. Verb-subject. Object-word order rare in the world, but standard in both classical Goidelic Celtic and Zenati Berber dialects. Lenitian softening of consonants at the start of words based on grammatical context, another shared quirk. Root-based verbal morphology, not the tidy tree of Indo-European conjugations, but a sandstorm of roots and patterns that change depending on rhythm, tone, and social register. It didn't fit the model. Celtic was supposed to be Indo-European, clean, Germanic adjacent, safe. But Goidelic Celtic, spoken in early Irish, Scottish Gaelic, and Manx, has always been the outlier. Its syntax bends in ways that defy the Indo-European blueprint. And so does Berber, especially the older Zenati forms, spoken from the Rif Mountains to southern Tunisia. Wagner wasn't alone forever. In 2003, comparative linguist Václav Blažek reopened the case. He mapped syntactic structures across Berber and Insular Celtic, showing not just superficial overlap, but deep architectural resonance. Sentence by sentence, rule by rule. Still, mainstream academia called it fringe, coincidence, interference, fantasy. But then came the DNA. In 2018, genome-wide studies revealed overlapping maternal and paternal haplogroups U6, EM81, and even ancient R1BV88 stretching from Atlantic Morocco into Iberia and north into the Celtic fringe. The languages weren't floating on coincidence. They were floating in blood. So the question sharpened. Can grammar survive the collapse of a culture? Can syntax be an inheritance? Can identity pass not only through DNA but through sentence structure? Most scholars dismissed this as fantasy until new DNA reignited the debate. And now, buried beneath Spain in the oldest melting pot of all that fire is rising again. Not in libraries, not in legends, but in bones, in base pairs, in the double helix of two worlds that once bled into each other. Iberia isn't just where Europe meets the sea, it's where the Sahara once kissed the Atlantic. Because here in the soil beneath Seville, in the caves outside Lisbon, we find the fingerprints of two ancient migrations, one from the north, one from the south. EM81, the North African Y-DNA haplogroup, appears in ancient Iberian remains dating back to the Neolithic, around 5000 to 3000 BCE. This wasn't the result of Roman trade or Moorish conquest. This was before history had names, before Carthage even dreamed of sails. The genetic evidence suggests a prehistoric pulse, a wave of Berber-linked populations arriving by sea, by land, or both, and settling into the Iberian coasts. But they weren't alone, because around 2500 BCE, R1BM 269, the Celtic signature enters the Iberian timeline, likely from Atlantic France. These two lineages, one from desert blood, one from ocean clans, don't just appear, they coexist, sometimes in the same site, the same graveyard. The modern result? A nation born of opposites. Spanish and Portuguese men today carry roughly 65–75% R1b, but in southwestern pockets, up to 10% still bear EM81. That's not a footnote. That's a forgotten chapter. And the culture, it remembers. Flamenco, its rhythms drawn from African scales, its tones bending like the Berber Islan. The mysterious duende, the spirit that seizes the voice mid-song, feels older than Andalusia. And in Galicia, the gaita, their bagpipe screams not just with Celtic wind, but syncopations more familiar in Saharan chants than Scottish reels. So who are the Iberians? Descendants of Roman roads? Of Moorish courts? Yes. But deeper than that, they are the children of a time when sea and sand were one, and language had not yet separated memory from melody. But this is not where the trail ends. Because beyond Iberia, the last witness still stands surrounded by waves, a volcanic outpost where genetics froze in time, the Canary Islands. And what we find there will shake the entire story. The Canary Islands. And what we find there will shake the entire story. Because these islands, silent now, beneath volcanic mist, held on to something the mainland forgot. Not in legend, not in language, but in blood. The Guanches, the first people of the Canaries. Tall, fair-skinned, often described by early Spanish chroniclers as having light eyes, reddish or brown hair, and rituals unlike anything seen in mainland Europe. They built stone towers, wrapped their dead in leather and reed, practiced intentional mummification centuries before the Spanish ever arrived. But their origins, a mystery, until DNA spoke. In 2009, geneticists studying ancient Guanche remains made a revelation that rewrote prehistory. The Guanches were not a lost island tribe. They were Berbers, direct carriers of mitochondrial haplogroup U6 and Y-DNA EM81. The same maternal and paternal lines still found today in the Atlas Mountains of Morocco. This wasn't colonization, it was continuity. The islands were settled as early as 1000 BCE, maybe earlier by seafarers from North Africa, long before Phoenician maps and Roman sails. And for nearly 2000 years, they stayed isolated. No Islam, no Latin, just ritual and memory, frozen in obsidian. And then, something stranger. Genetic overlap not just with North Africa, but with Atlantic Europe. The Guanche U6b1 lineage shows up again in ancient Galicia and, faintly, in coastal Ireland. Is it a coincidence, drift, or the trace of a forgotten triangular corridor, Maghreb, Iberia, Isles? Either way, the Canary Islands didn't just preserve Berber blood. They preserved its purity until the 15th century, when Castilian forces arrived, and with them conquest, disease, collapse. But even now, Canarian populations retain 42% of maternal Guanche ancestry. It's not a memory, it's a living fossil. And so we ask, if the Guanche held Berber identity in isolation, who else might carry it in plain sight? Because across the sea, in the mist-drenched highlands of northern Scotland, one rare marker keeps surfacing, and no one knows how it got there. It's called EM81, the unmistakable signature of Berber paternal lineage, found across Morocco and Algeria in frequencies as high as 80%, but in Scotland, it shouldn't be there at all. And yet, it island, traced in small scattered samples, most notably in the Western Isles, the Hebrides and coastal parts of Argyll, just a fraction of a percent, but consistent, quiet, refusing to vanish. It first surfaced in a 2005 Y chromosome survey led by the University of Leicester, dismissed at the time as statistical noise, an error, a fluke. But when follow-up studies in 2011 and 2017 confirmed the same result, the silence grew louder. There are two theories. The first contact, older than Rome, prehistoric maritime exchange, stretching from Iberia, through Brittany, across to the Irish Sea. Echoes of a time when boats hugged the coasts and carried more than salt and fish. They carried lineages. The second, more recent, yet equally haunting, because in the year 208 CE, the Roman Emperor Septimius Severus himself, born in Leptis Magna, North Africa, stationed thousands of soldiers across Britannia, among them Numidian cavalry. Berber tribesmen on horseback, serving under the Eagle of Rome. Their barracks still stand, Vindolanda, Hadrian's Wall, stones carved with North African names, gravestones bearing Latin words for sons and foreign wives. What if one stayed? What if a single soldier from the Sahara fathered a line that vanished into the mists, only to whisper again 2,000 years later in the genes of a red-haired Scot? And, deeper still, beyond the genetic data, something older stirs. Carvings on Pictish stones, the double spiral, the sun disk, near identical to Neolithic motifs from Tassili Anajer, separated by deserts, by centuries, but maybe not by story. We've hunted history through empire and battle. But what if the truth lived instead in tiny islands, in forgotten men, in the curves of stone? Because if Berber DNA exists in Celtic lands, what other lineages are hiding in plain sight?